Hey everybody, we are learning about error and power today, and hopefully you looked through the error lesson first because you really need to understand what a type 1 error and a type 2 error is before we look at power. So if you didn't, please pause the video and then go look through and practice the two different types of possible errors that we can make when we run a hypothesis test. And I'll meet you back here in a little bit. Okay, so now that we're ready to do power, first things first. The big idea behind power is that it's really a conditional statement about if the alternative hypothesis in a test is actually true, what's the probability that we rejected the null hypothesis? That's the power of a test. Did we actually reject the null hypothesis correctly? So we're going to go through and we're going to investigate calculating power, which we really don't do by hand, but we have an applet that's going to help us out. So situation, remember back when we were looking at free throw shooting? Well, we're trying to decide if in this time Mrs. Wood will prove herself. So recall that Mrs. Wood claims she is an 80% free throw shooter. Mr. Wood is skeptical and believes that she is a less than 80% free throw shooter. Mrs. Wood has decided to take another simple random sample of 53 free throws to prove herself. So here's our null, here's our alternative, and we are going to use a simple random sample of 50. Okay, first things first, let's write our appropriate hypotheses for this significance test. And we will include what the true proportion is about, our parameter. So our parameter of interest is the true proportion of free throws that Mrs. Wood actually makes. Our null hypothesis is that she is an 80% free throw shooter. We'll see about that. Our alternative hypothesis is that she's not. And that, in fact, Mrs. Wood, myself, is worse than, I put 85, an 80% free throw shooter. Okay, so a type 2 error in this setting would be, let's talk about what the definition of a type 2 error is. Let's quickly review it from the last lesson that you were supposed to have already done. So a type 2 error, if we define it off to the side, is when we fail to reject the null hypothesis, but we should have because the null is false. So we didn't reject the null hypothesis. We think that Mrs. Wood is actually an 80% free throw shooter, but we should have because the null hypothesis is false. That's technically a type 2 error. Now, that's not a description of it in context in this setting. That's just the definition of it. So we have to start there, and then once we know that in our head, we can go ahead and write something in context. So if we didn't reject the null hypothesis, then we think that Mrs. Wood is an 80% free throw shooter. Okay? So the type 2 error in this setting would be us believing that Mrs. Wood is an 80% free throw shooter. But she's actually worse than that. Oops. all the evidence we've collected led us to believe that Mrs. Wood is in fact an 80% free throw shooter. However, our evidence led us to a mistake, which happens. We know that when we are looking at different significance levels, that we aren't 100% confident in our results. And so that little bit that's left over is that chance of making our errors, okay, which hopefully made sense when you looked at the error section. Okay, number 3, suppose that Mrs. Wood's true free throw percentage is actually 66%. So I lied. I'm not really an 80% free throw shooter. So when we're doing this situation, in order to run calculations with type 2 error and power and all that stuff, this value here, we have to be given that value. I don't want you to think that that was something that you should have known or been able to come up with. If they're going to have you do any sort of calculations, you have to be given that value, okay? So enter this information into the applet, and then we're going to click to display the type 2 error. It will show up as a blue shaded region. So go ahead and pause the video for a minute and fill in all the information and see if you can come up with the correct probability of a type 2 error, meaning we were wrong, we made a poor decision, and the probability of a good decision here, the power of a test. Okay? I'll see you in a minute. Okay, if you filled in all the information correctly, you would see that the probability of a type 2 error is 0.24 or 24%, which means the power of the test, the probability that we were correct, is 76. So let's get those values filled in, and you should be checking yours and making sure they are correct. And then interpret this probability, okay? So in order to make the interpretation of a good decision, let's talk about what that means a little bit and define it off to the side here. So remember that the type 2 error, just a quick review, plus the power is equal to 100%. Hopefully you realized that by looking at the 24 and the 76. Those two add together to give us 100%. Either we're wrong or we're right, okay? If we're looking at the probability of a good decision, this is a conditional setting. So we're really looking at the probability of rejecting the null hypothesis if the alternative was actually true. So we have to take that idea and make it into something that uses the context of our situation. Okay, so we're going to start with our if part, because a lot of the times when we write conditionals, we start with the if, the given, and then we write what comes of it. So if we start there, we're going to say if Mrs. Wood really is a 66% free throw shooter, if the alternative is true. So if Mrs. Wood really is a 66% free throw shooter. So if I really am less than 80%, then there is a 76% probability, that's the power of our test, that we would correctly decide that Mrs. Wood is less than an 80% free throw shooter. Or you could say that we would correctly decide that Mrs. Wood is not an 80% free throw shooter, right? So just to clarify, this very first part here was our alternative hypothesis. So if that's really true, then the power is the probability that we correctly rejected the null hypothesis. Okay, so I just wanted to outline it there. It's a lot easier to memorize the definition of power and error when it's not in the context of a situation. Trying to get it formulated in context makes it a lot more challenging. So for some of you, it's just going to take some practice and repeating until you've got this down. Okay? Let's play around. We're going to click on the display of that same applet that now says power, and we want you to figure out how you can increase the power of the test. So play with it a little bit and choose each one separately. So increase the sample size, then put it back. Increase and decrease the significance level, which is alpha, and then put it back. Increase or decrease the alternative, which was the one we chose. That was my 66%. And then put it back and see which of those actually affect the power. Okay? And then meet me back here and we'll check and see how you did with it. Okay, so hopefully you found through all that we increase the sample size in order to increase the power of the test. For the significance level, we would also increase that value to increase the power of the test. And for our alternative hypothesis, we would want to decrease the true value if we wanted to increase the power of our test. Okay, and when you played around with the applet, hopefully you found these three responses and were able to correctly choose them. So that is how to play around with power and with definitions of how it relates to the type 2 error. Okay? In the AP exam, there are usually very few questions on power, I'm going to be honest, but it's still something that helps you make some connections between the types of errors and the flowing of which one would increase and decrease and so on. Those are good multiple choice type questions. Okay? Let's look at that check for understanding problem just in case you still need a little bit more support on this. So in the check for understanding problem, it says that a statistics major and a finance major decide to get married. In order to investigate their per person expenses, they select a random sample of guests that they've invited to the wedding and record whether or not each person plans to attend. They decide that the null hypothesis is going to be 0.75 versus the alternative, which is just not equal to 0.75. And the proportion for our parameter for the population is going to be the true proportion of all guests that will actually attend the wedding. So important information through here is just going to be that we have a simple random sample, not simple, sorry, just random, and that we have our null hypothesis and our alternative hypothesis, and then the information, the true proportion of all guests. So notice that I outlined or highlighted the null and alternative in orange. That's usually part of your setup information at the beginning of your problem where you state what you know. Always remember you want to state the null and alternative hypotheses before you figure out any errors or power information. You have to be able to look at those two and compare them, okay? So more information. Part A says the power of the test to reject the null when using, when the true proportion is actually 0.7, using a significance level of 5% and 25 for our sample size is 10%. That was a lot of loaded information in the middle of that sentence. So I'm going to highlight what the question truly is. The power, oops, that was the wrong color. The power of the test is 10%. And then we are going to go through and interpret that. Okay, so if we're going to go through and interpret it, remember this is the conditional setting for power. Okay, so start thinking about how you think it should sound. If the alternative is true, then the power is the probability of rejecting the null. Okay? Maybe pause and see if you can get that into words. Okay, here we go. If the true proportion, oops, I'm still on highlighter. If the true proportion of all the guests that will attend the wedding is in fact 70%, then we have a 10% probability, that's the power, of finding convincing evidence to reject that the true proportion is 0.75. Okay. That's not very powerful. There's only a 10% probability of finding convincing evidence that the true proportion is not, in fact, 0.75. That should make sense to you because the true proportion is 0.7. That's not that far off. So most likely, if we collect samples, then we're not going to be convinced that 0.75 is wrong. Okay? So just trying to put it into perspective for you. Now, if the alternative truth was way further off than 0.75, maybe it was more like 0.5, then the power would increase and we would have a much higher chance of being able to find convincing evidence that it's not 0.75. Okay? Okay, so then we get to play with part B, and that truly is more of the type of questions that would be asked in like an AP exam or test setting. So they gave you the background information that you need to do part B without the applet. So the probability of finding a type 1 error is just our significance level. So there is a 5% chance that we would make a type 1 error. For the type 2 error, and this is a good review from the lesson that you did on your own at the beginning. For type 2 error, it's 1 minus the power. We weren't told anything about type 2, but we know that the type 2 error plus the power is 100%. You either made a good decision or you made a bad decision. So if we know that in this situation, the power is 10%, then we know that the chance of a type 2 error is 90%. Okay? Again, just using the numbers up above. Here was our power, remember, up there in green. Here is our significance level. I circled them up there for you to help you find them. This last question is really just using the applet again and filling in the numbers. So open up that applet, put in the information for alpha being 0.1 instead of 0.05, and check out whether the power would increase or decrease. And then do the same thing for the sample size. Come back and check your answers. Okay, hopefully you found that the power would decrease if we reduced the significance level of the test. Okay? If we reduce the significance level, we increase the chance of a type 2 error. We're going to make one type of error as our possibilities. So if we decrease one, the other one increases. If we increase the chance of a type 2 error, then we've decreased our power. They're all plays of inverses. Hopefully you're able to see that. Okay? Increasing type 1 meant we decreased type 2, which meant we increased. Oops, sorry. I went backwards there. Decreasing type 1. I was saying all those right. It just wasn't our situation. We decreased type 1, which would increase type 2, which would decrease the power. That's what they asked. There we go. Okay. Sample size, same idea. Okay. If you increased the sample size, that should also, in effect, increase the power. So increasing N increases the power of your test. Okay? More likely to make a good decision. Hopefully you don't have any questions left, but remember you can meet in Hub if you do have some questions and want to go over anything. Good luck with your Khan Academy and your FRQ for today, and have a great rest of your day, you guys.